Okay, question number 12. Consider non-zero vectors for u and v. Let theta be the angle between u and v. Using the definition of scalar product and the cross product of two vectors in terms of u, magnitude of u and v, and theta, show that this equation are true. So see that this equation over here. So u dot v by definition, u dot v is vector u magnitude, vector v magnitude of cosine of a theta. So everything is squared plus the definition of u cross product of v of absolute value is the area of a parallelogram created by u and v, which is u vector, absolute value, v vector, absolute value of sine of theta. So this one is squared. Yeah, I need to show this. So this one is u vector squared, v vector magnitude squared of cosine squared of theta, plus u vector squared, v vector squared of sine squared of theta. So you can factorize this expression. So you can see u vector v vector squared in front. It's going to be cosine squared theta plus sine squared theta. By trigonometry identity, this one becomes 1. So it's u vector, absolute value of v vector squared, absolute value of v vector squared, which is right hand side. It becomes same. Okay. A triangle ABC has a vertex A, B, and C, where inside of B there's PQ, where PQ is a rational number. The vector u and v are defined as u is a to the b, v vector is a to the c. It's given that u dot v is 3 and the area of triangle is ABC is scalar of 6. Find the value of u cross product of v of absolute value. So we can draw a picture to make us better understand the situation. So triangle ABC, we can draw like this. Let's call this A, B, C, and coordinate is given here. So we defined A to the B is as a u vector. So this vector here is the u vector, and the A to the C is v vector. So this vector here is a v vector. And the u dot v is 3, and then triangle area is square root of 6. So area of this triangle is square root of 6. So find value of u cross product of v magnitude of uv. So by definition, uv, so let's see, this is u vector squared of v vector squared of a sine of theta. So this is the magnitude of u cross product of v, which means that this area, this is area of parallelogram created by u and v. This u and v area parallelogram is like this this whole area is the magnitude of u cross product of v. So this whole area is 2 times of this area, right? So the answer is going to be 2 times square root of 6. Hence or otherwise, find value of v vector, u vector magnitude. So it says hence over here, this big clue, hence here, meaning we have to use this equation here, So what is given is the question already given us that u dot v is 3, which is over here. We know this value, and then we already find out the u cross product of v absolute value is 2 to 6. This is known value. We need to find out u magnitude of u, which is here, and we already need the v vector magnitude square. So v vector here, we need to find magnitude square. So we need to find the v vector exactly. So v vector is defined from A to C. So from A point to the C point, v vector. So we can see x is increased by +3, +1, -1, right? The v vector is 3, 1, -1. So put all this information into that equation, we will get u dot v squared, which is 3 squared, plus u cross product of v absolute value squared, which is 2 square root of 6 everything squared. Let me rewrite this a little bit, make it clear. 2 square root of 6 everything squared equals u vectors of square times v vector square. V vector square is v vector's magnitude square. So v vector magnitude is square root of 9 plus 1 plus 1 everything squared. Okay, let's solve this. This is going to be 9 plus 4 times 6 is 24 equals u vectors squared. This is square root 11 squared is going to be 11 here. So left hand side with the 33. So we get here u vector magnitude of u vector squared is 3. So what we know, u vector's magnitude must be square root of 3. Hence or otherwise, find the possible value of p corresponding value of q. How? So we need to know, we already know that u vector magnitude is square root of 3. U vector, so u vector. Okay, this u vector is defined. So vector from A to B. So it's going to be P Q minus 1, 1. So magnitude of that vector is square root of 3. There's one equation about P and Q. We need one more equation, which is ABC triangle area. And then u dot v is 3. So right? So we need to use two equations to find this. First condition, we're going to use this one. Second condition, we're going to use this condition. So out of this condition, u dot v. So we need more space. So where should I put it? So u dot v. So p, and I'm gonna not write. So this vector cross product of this vector equals 3. So calculating this condition, so it's gonna be 3p plus q minus 1 equal 3, which give us 3p plus q equals 5. This is first condition. Second condition is u vectors of magnitude is square root of 3. So u vector magnitude is square p squared plus q minus 1 everything squared plus 1 equals square root of 3. So from these two equations, we need to find p and q. So let me get this. I need more space, so let me get these two equation into somewhere I can see. So these two, everything I need to move ahead here. Yeah. Okay, let's get rid of this circle here, and then this equation down there, we can just get rid of the square root. Yeah, by taking the square on both sides, and then yeah, from this equation here, so we can say q equals 5 minus 3p. Entering over here, we'll get p squared plus 5 minus 3p minus 1 will give us 4 minus 3p squared equals 2. Yeah, we need to get point of p. So because this is paper 2, we don't have to do struggle, so just use a calculator to get the answer. Close and delete it, and the second quit, and clear everything. Let me see. Go to y2, and then x squared plus 4 minus 3x squared. 3x undo parenthesis close and everything squared minus 2. We need to find 0 of this function. That gives us p equal 1, p equal 1, or p equal looks like 1.4. So when p equal 1, q is 5. When p equal 1, q equals 5 minus 3 times p is 1. Yeah, q equals 2. When p equals 1.4 is 5 minus 3 times 1.4. Q equals 0.8. So this is the answer. Okay, now consider the new point D. The vector W is defined as W is C to the D. It is given that U dot V and V dot W is 0. And then area of triangle ACD is 5 square units. Assuming that P equal 1, find the possible vectors for W. Assuming P equals 1, which means that we are using P equal 1 using this condition here, so that automatically means that P equals 1 and then Q equals 2. And then U dot W, V dot W is the W vector is some vector defined from C to the D point, some D point. And it says this vector, the condition here is perpendicular to U, and W vector is perpendicular to U and perpendicular to V, because scalar product is 0. So W vector is like this one is 90 degree, and then this one is 90 degree. So pretty much W vector, even though it starts from C, something like this, but it's same as putting over here, and then this angle is 90 degree and this angle is 90 degree. These two vector is same vector, which is W vector. Okay. Area of triangle ABACD is 5. So we have 5 conditions. So let's say W vector is defined as W vector defined as ABC vector. Okay, so first condition, this one over here, U, which is U vector now P equals 1, Q equals 2. So U vector is now 1, Q equal 2, right? Q equal 2. So 1, 1, 1. This is u vector. V vector is still 3, 1, negative 1. So P vector, u vector is 1, 1, 1. Cross product, no, dot product of w vector A, B, C equals 0. V vector was what? 3, 1, negative 1. 3, 1, negative 1. Dot product of A, B, C equals 0. There are two conditions and three unknowns. We need one more equation to find ABC. And then third condition, ACD, the triangle area is 5. As you see, ACD. So ACD, this triangle, so this triangle is same as this triangle, right? Area is bottom to height times half. So bottom distance is v vector squared. This one squared, height with this distance of this vector times half is got it. So third condition is bottom vector, which is 3, 1, 1. So square root of 3 squared is 9 plus 1 plus negative 1 squared is 1 times height is square root of a squared plus b squared plus c squared. This times 1/2. This is the area of triangle, which is 5 square units. So out of this condition, we need to find ABC, that is this factor W. So first condition, we got A plus B plus C equals 0. From second equation, we got 3A plus B minus C equals 0. Third one, just simplifying the third equation, we got this one, just delete it and make right side 10. And then squaring both sides, take a square both sides. We'll get it's gonna be 11 a squared plus b squared plus c squared equals 100. So taking 11 down here and then just delete the parentheses. So this 3, we can use these 3 equations to find the ABC. Just eliminate how do you find? We can eliminate B and C into just making one A. So adding these two equations will give us 4A plus 2B equals 0, which means that B equals minus 2A. Yeah? And then subtracting this one to this one will get a little of B. So which minus will be minus 2A plus 2C equals 0, which means that C equals A. So putting this to equation over here, so we got the A squared plus B squared. B is negative 2A squared is 4A squared plus C squared. C squared is also A squared is 100 over 11. So we can calculate this one by using the calculator. So in this case, we have to use functions graph. So it's going to be 6A squared equals 100 over 11. So A squared is 100 over 66. So A equals square root of this one. So click on quit. Square. No, don't make mistake like this. So A is gonna be plus and minus square root of 100 over 66 equals square root of 100 divided by 66. So A is gonna be plus minus 1.23. So let's say A equals 1.23, A equals minus 1.23. There are two possibilities. When A is 1.3, B equals minus 2A, so minus 2 times minus 246. B equals minus 2.46, and C equals A, so 1.23. So this is first set. Second set is this one, B equals plus 2.46, C equals minus 1.23. So this is going to be the answer.